So today we will explain the case of complex conjugate roots. Okay, so first the structure in context of structure of the time path, in context of complex conjugate roots, and then we need to understand why the time path will be oscillatory here. Now, when the time path will be oscillatory, the oscillations may be damped oscillations, explosive oscillations, uniform oscillations. So, along with why the time path is oscillatory in case of complex conjugates, we need to understand the issue related to convergence and divergence as well. So, I hope the things were understandable for the distinct real roots and the repeated real roots. Are these two cases okay with all of you?
Yes, ma'am.
Okay. So if we look at the nature of the discriminant, the roots will be complex conjugates if m by n whole square is less than -4 beta plus delta by n. So once again, let's look at the structure of the roots. So this is the root, and this is the discriminant part. This is the discriminant part. So if this part is less than this part, so in that case, there will be the problem. Okay. So this is the thing. If m by n whole square is less than -4 beta plus delta by n, in that case, there will be a problem. Okay. So in that case, we can present R1 and R2 as H plus minus Vi, where H we are considering minus m by 2n, whereas V is half into root over m by n whole square plus 4 into beta plus delta by n. So if we go back to the root values once again, so better I just copy the root values there. Okay. So I'm considering, this first part, minus m by 2n, that as h, and then this part divided by 2, this is as v. So can we write R1 and R2 in the form h plus minus vi? Everyone? If the roots are complex conjugates, can we write the things in this way?
Yes, ma'am.
Everybody is understanding this? There,
Yes, ma'am.
the real part, minus m by 2n, that I am writing as h, and the other part where there is the complex number, that I am writing as vi. Okay, and plus minus sign is already there. So we can present it as h plus minus vi. Then we are telling that the general solution will be given by e to the power ht into a1 e to the power vit plus a2 e to the power minus vit plus alpha plus gamma by beta plus delta. So let's look at the standard structure of the time path. This was the standard structure of the time path. So if this is the standard structure of the time path as it has been discussed yesterday, so, if I consider this to be h plus minus vi, so actually there are two values, h plus vi and h minus vi. Okay. So for R1, if I consider this to be h plus vi, and for R2 2, if I consider h minus vi, e to the power ht is common in case of both the exponentials. So I can take e to the power ht common, and it is a1 e to the power vit. So if you multiply this term with e to the power ht, it is becoming a1 e to the power ht plus vit. And if you multiply eht with the second term, it is becoming a2 e to the power ht minus vit. So I hope you are understanding. I can take e to the power ht common, and rest of the part will be a1 e to the power vit plus a2 e to the power minus vit, and there will be alpha plus gamma by beta plus delta, which is equation number 9. So this is the structure of the time path when the roots are complex conjugates. Is it understandable? Are you understanding equation number 9? Any doubt, any clarificatory question? Next.
Ma'am, could you just repeat this part once again?
Equation number 9?
Yes, ma'am, yes.
Okay. Last day we got this kind of structure for the time path of price here.
Yes, ma'am.
Any problem, in the standard
No.
structure of the time path?
No, ma'am.
Okay. Now the possible values of roots are R1, that is equal to h plus vi, R2 h minus vi. So is it clear?
Oh, yes, ma'am. Yes, ma'am. Got it.
Okay.
Sorry.
So in place of R1, I am writing h plus vi. In place of R2, I am writing h minus vi. So basically, ht plus vit, and here ht minus vit.
Minus V. Yes,
Okay.
got it.
And I am taking e to the power ht common, and I am getting this result.
Yes, thank you, ma'am.
Okay. Okay, so everybody is understanding equation number 9, I hope. Okay, you have to understand equation number 9 very well, because rest of the discussion will be based on this equation number 9. Okay, so in the rest of the part, we will explain how from this structure using trigonometry, we can present it in terms of sine theta and cos theta, and then applying the principle of derivatives of sine theta and cos theta, how we can explain, the time path will be oscillatory in nature in this case. In case of equation 9, the time path will be oscillatory. Okay. So let's transform the imaginary exponential expressions in the parenthesis. That means e to the power vit and e to the power minus vit, this part. A1 into e to the power vit plus A2 e to the power minus vit into equivalent trigonometric expressions, so that we may interpret the complementary function as a circular function. This circular function in turn will generate a cyclical time path of price. Okay, so using trigonometric expression from these parentheses, we will go for a circular function, and from the circular function, we will derive the cyclical time path of price. Okay. Okay, now before going to that part, I want to add something regarding the stability part. Okay, when the time path will be convergent, when the time path will be divergent, etc. Now, if I look at this structure, the time path will be convergent if this entire first path moves towards 0 as t tends to infinity, this entire part. this first part. If this first part moves towards 0 as t tends to infinity, then the time path will be convergent. Everybody, are you understanding this statement? If this yellow part tends towards 0, then the time path will be convergent.
Yes, ma'am.
Yes.
Okay, because the second part is nothing but equilibrium value of price. Okay. Now, if we look at the first component e to the power ht, now if the value of h is negative, if the value of this h is negative, in that case it will be a1 e to the power vit plus a2 e to the power minus vit divided by e to the power ht. If h is negative, this part will come in the denominator. In that context, as t tends to infinity, the entire e to the power ht will move towards infinity. E is a mathematical constant. So if t tends to infinity, the power tends to infinity, in that case, the entire e to the power ht in the denominator, that will move towards infinity. Is it acceptable?
Yes, ma'am.
And if e to the power ht, this entire term in the denominator, moves towards infinity, then what will happen to this first yellow term?
It will tend towards 0.
It will tend towards 0.
10 to 0.
Very good. It will tend towards 0. So what I am telling, if the h is negative, if the value of h is, the sign of h is negative, okay, if it is negative, then the time path will be convergent in nature, otherwise it will be divergent. So this is a big thing, and when we will convert it with the help of trigonometry, etc., it will be in terms of sine theta, cos theta, etc. Whatever be the thing, convergence will depend on the term h. If h is negative, that means in this case minus m by 2n is negative. Okay, if m and n are positive, then it will be negative. Okay, if m and n both are negative, then also it will be negative. So there are several conditions by which we can have h to be negative. So anyhow, if h is negative, then the time path will be convergent in nature. Otherwise, the time path will be divergent in nature. So please take note of this fact. Okay. Once we get equation number 9, okay, please take note of the fact that in the first term in the right hand side, if h is negative, in that case, the time path will be convergent. Otherwise, it will be divergent in nature. If anyone have any query, any question, please ask me regarding the convergence condition. Okay. So if the convergence condition is clear, we can move to the next part. It will be a longer thing because we will use several concepts which you earlier learned in different courses. So next we are moving towards this. In the first step, we consider the exponential, any standard exponential.
Ma'am, sorry, ma'am, to ask again.
Yeah.
Ma'am, in this here, minus VIT, ma'am, this will not place any effect above the above portion as t tends to infinity. This value will not grow big.
Will you please repeat your question once again?
I am saying what will happen to the numerator as t tends to infinity, means it will not play any role. Only the denominator is.
Yeah, for the convergence, for the convergence condition, we will consider only the real part. Okay, so if you consider only the real part, you don't need to look at these parts. Okay, you don't need to consider the imaginary part for developing the convergence condition. If your denominator, whatever happens to the numerator, if your denominator tends towards infinity, then this entire part will move towards 0. So we will not focus on the imaginary part when we will consider the convergence condition. We will look only at the real part of the root. However, to understand the other part of the time path, that is why it is oscillatory, why I am telling that when the roots are complex conjugates, we will have oscillatory time path of price. To understand this part, we have to focus on the imaginary part. Okay, Ayan, got it?
Yes, ma'am. Yes, ma'am. Got it.
So next we are considering the series of exponential, any series of exponential, e to the power x. Okay, are you familiar with this series? E to the power x, exponential to the power x?
Yes, ma'am. Yes, ma'am.
Okay, so it is 1 plus x plus 1 by 2 factorial x square plus 1 by 3 factorial x cube plus 1 by 4 factorial x to the power 4 and so on. Okay. Now, in place of x, suppose I am writing I theta. Why I am writing this thing? Because first of all, I have it, VIT. Okay, so I have VIT like things. Okay, therefore I am bringing I here. Instead of x, I am bringing the imaginary number here and imaginary number multiplied with some constant, say theta. Now, why theta? Why not ABCD, rather theta? Because as I mentioned, using trigonometry here, we will move towards the sine theta, cos theta kind of structure. Therefore, instead of considering any ABCD, I am considering theta as the constant. Okay. So, in the above expression, that is in the expansion of the exponential, instead of x, suppose we are considering the number I theta. Okay, so the series becomes e to the power I theta is equal to, so I am bringing the imaginary number I. So e to the power I theta is equal to 1 plus I theta whole squared by 2 factorial, I theta whole cube by 3 factorial and so on. So first, tell me whether this line is understandable. Simply, I have extended this for the imaginary number I theta. So first line is understandable?
Yes, ma'am.
Yes, ma'am.
Then I am applying the nature of the imaginary number. Okay. Now, what is I square?
-1.
-1.
So let me check. I square is equal to -1. I cube is equal to I to the power 4 is equal to 1. I to the power 5 is equal to I. So you know all these things. Okay. So 1 plus I theta, I'm keeping intact. Then I'm replacing I square by -1, I cube by I to the power 4 by +1, I to the power 5 by I, okay, and so on. So please check this line. If there is any mistake, any query, please ask me. Anyone, any question? If you feel that this will be a very simple question, then also please ask me. So it's fine to all of you, I think. So next what I am doing, I am separating the real part from the imaginary part. So 1 minus theta square by 2 factorial plus theta to the power 4 by 4 factorial minus theta to the power 6 by 6 factorial, all these things will come here. And here I, theta minus theta cube by 3 factorial plus theta 5, theta to the power 5 by 5 factorial, etc. So is this line okay to all of you?
Yes,
I
ma'am.
hope you are understanding. I have two parts in my time path, e to the power vit. For e to the power vit, suppose vt is equal to theta. Suppose vt is equal to theta. So then the expansion will be like this. Expansion will be like this. However, I have another root as well, which is giving me e to the power minus vi theta. So e to the power minus I theta. Okay. Similarly, setting x is equal to e to the power minus I theta, the following result will emerge. So e to the power minus I theta. So first I am considering the E series. Just e to the power x, 1 plus x by 1 by 2 factorial x square. So all x will be replaced by minus I theta. All x will be replaced by minus I theta. So first I am doing so. And then I am putting the values of the following the rules of the imaginary numbers. And in the similar fashion, I am splitting the entire expression, the polynomial, into the real as well as imaginary part. I am subdividing this series into the real and the imaginary part. So check up to this. If there is any mistake, any question, please ask me. So is it fine to all of you? Now, so I have e to the power I theta equivalent to this and e to the power minus I theta equivalent to this. Now, using Euler relation, we get sine theta, sine theta. So I'm just going for Euler's relation. So using the Euler's relation, we get sine theta is equal to theta minus theta cube by 3 factorial plus theta to the power 5 by 5 factorial minus theta to the power 7 by 7 factorial, etc. Whereas cos theta is equal to 1 minus theta squared by 2 factorial plus theta to the power 4 by 4 factorial minus theta to the power 6 by 6 factorial, etc. So sine theta comes with the odd powers. Cos theta comes with the even power. Okay. So just the expression we are looking above, if you look at this thing, can you tell me whether the first part is following sine theta or cos theta? So in cos theta and sine theta, how I can write this last expression?
Cos theta minus I
Minus
sin.
I sin theta.
Cos theta minus I sin theta. Very good. Cos theta minus I sin theta. And from this expression,
Cos theta plus I sin.
sine comes with this part, cos theta comes with this part. So this is cos theta plus I sin theta, and this is cos theta minus I sin theta. Okay, So only the difference between plus minus. So this can be presented in terms of cos theta and sin theta then. So e to the power plus minus VIT can be presented in terms of cos theta and sin theta. Is this acceptable to all of you?
Yes, ma'am.
Other students?
Yes, ma'am.
Yes, ma'am.
Asking
Yes,
that
ma'am.
these equation number 9 can be converted in terms of sin theta and cos theta. Are you convinced?
Yes, ma'am.
Okay. So thus, as you mentioned, e to the power I theta is cos theta plus sin theta, e to the power minus I theta is equivalent to cos theta minus I sin theta. These will enable us to translate any imaginary exponential function into an equivalent linear combination of sine and cosine functions and vice versa. Okay, so before coming to all these things, so in our expression, theta is equal to Vt. Theta is equal to Vt. Everybody, in our expression, theta is equal to Vt. Is it right or wrong?
Yes, ma'am.
Yes, ma'am.
Okay. So e to the power Vit can be written as cos Vt plus I sin Vt, and e to the power minus Vit can be written as cos Vt minus I sin Vt. So the time path can be presented as e to the power ht was there, a1, e to the power Vit, I am replacing it by cos Vt plus I sin Vt, plus a2, e to the power minus Vit, I am replacing by cos Vt minus I sin Vt. So this is the expression. So what I can do, I can take cos part common and sine part common, and I can write the expression as e to the power ht a1 plus a2 cos Vt plus a1 minus a2 I sin Vt plus the equilibrium. This a1 plus a2 is a constant, so I can replace it by another constant a3. a1 minus a2, this is also a constant. I can present it by a4. So finally, I can write the time path as pt is equal to e to the power ht a3 cos Vt plus a4 sin Vt plus the equilibrium. Now the value of h, that was minus m by 2n. So if you want to replace h, you can rewrite the time path as pt is equal to e to the power minus mt by 2n into a3 cos Vt plus a4 sin Vt plus pe. So please look at this expression. If required, go through the things once again and let me know whether you are agreed. Now this will be the shape of the time path if I present it in terms of cos and sine.
Ma'am, can you please say what an Euler's relation is? I do not know that relation.
I just, would you please repeat which relation you don't know?
Euler's relation.
Okay, so please check any mathematics book in Chiang 2, you will get the expression, you know, e to the power I theta can be presented, sorry, not this, you are talking about the Euler's relation. Sin theta can be presented in this way. This you will get from any trigonometry book. Okay, +2 level trigonometry book. Okay?
Okay, ma'am.
Have you done trigonometry at class 2 level?
Yes, ma'am. I did have trigonometry.
You didn't have?
I did have.
Okay, you did have. So please
Yes.
check the trigonometry book. Okay? So you will get this relation. Sine theta can be presented in this way, cos theta can be presented in this way. This is the mathematical relation. The proof is quite long, you know. So please check this thing from the mathematics book. Okay. So in case of economics, we are using all these relations. Okay, next, what I told you, you know, to check the time path once again. So if anyone have any question in adjusting the above time path and coming to the position with cos and sine, please ask me. And if you have problems with the Euler's relation, or if you ever didn't check the Euler's relation, you know, so please check any standard trigonometry book, you will get the relation. In Chiang too, we will get the relation. Maybe
Ma'am,
will not get the proof of the Euler's relation. I'm not sure. I check it whether the proof is there in Chiang's book. Yes.
ma'am, where did the I go from the second step? Is it part of A4?
This I part.
Yes, ma'am.
Yeah, when I'm writing, you know, I is here, you know, e to the power it itself is cos plus I sine. Minus I itself is cos plus minus I sine. Okay, or what was your question?
Yes, ma'am. That part I understood. But in the second step, we have A1 minus A2 I sine VT, right? So in the next step, where did this I go? Like, did it become a part of A4?
Yes. Yes, it is becoming a part of A4. Yeah,
Okay, ma'am. Okay, okay.
yeah. Yeah, that, okay, this is your question. A1 minus A2 into I. Yeah. A4 is A1 minus A2 into I. Yes. Okay, so this is the expression, and from this expression we need to understand convergence divergence part. I hope you understood. You need to understand, you know, why this kind of equation generates cyclical movement. This type of expression, something into cos plus something into sine, this kind of expression generates the oscillations. Okay, so already this thing I discussed, you know, the time path will be damped oscillatory, uniform oscillatory, or explosive oscillatory depending on age greater than, equal to, less than 0. So H part for convergence, etc., that I discussed. However, I need to explain this part, this note 1. For the sine function, we consider, say, phi of theta is equal to sine theta. Okay, for the sine function, let's consider phi of theta is equal to sine theta. So if I consider phi of 0, that will be sine 0 is equal to 0. Then if I consider the derivatives, go on taking the derivatives, first derivative, second derivative, third, fourth, fifth, etc. The derivatives will be phi prime theta. Derivative of sine theta is equal to first derivative of sine theta is equal to cos theta, that you know. I think all of you know this thing. In your trigonometry, you did this thing. First derivative of the sine theta is equal to cos theta.
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. So this part you know. So when I am taking the derivative of sine theta, it is becoming cos theta. When I am taking the second derivative, it is becoming minus sine theta, third derivative minus cos theta, fourth derivative plus sine theta. So it will go on like this. It will go on like this. Okay. So you can go on taking the derivatives. The values will be like this. Now I am setting theta to be equal to 0. Okay, theta to be equal to 0. As I mentioned, sine 0 is equal to 0. Phi prime 0, that means cos 0. Cos 0 is equal to 1. Second derivative minus sine 0, that is equal to 0. Third derivative minus of cos theta minus of cos 0 is equal to minus 1. Then 0, then 1. So what I am finding that if I present the expression in terms of sine theta and then we consider the continuous derivative with respect to say time, in that case, the expression will move within the bound -1 to +1. Okay, it will move within the band -1 to +1. For different, it is the minimum value is -1, the maximum value is +1, etc. So if I start with sine 0, in that case, the band will be in between -1 to +1. Is it okay to all of you? Please check this part and tell me whether this part is clear to all of you. Then I'll relate it with the time part later. So first check simply this note. I'm taking a function of theta which is equal to sine theta, and then we are taking the derivatives with respect to theta, and then we are putting theta is equal to 0, and we are getting the range within -1 to +1. So please check whether you are understanding this part or not. If you have any question, please ask me. So is it okay?
Yes, ma'am.
Yes, ma'am.
This will generate the following Maclaurin series with the remainder sine theta is equal to 0 plus theta plus 0 minus theta cube by 3 factorial plus 0 plus theta to the power 5 by 5 factorial plus up to this. So are you familiar with the Maclaurin series? In the first semester, you did it? In your Matheco course?
Yes,
We
ma'am,
did
we
the
did it
Taylor series.
briefly with the Taylor series when the term is 0.
So are you familiar with the Maclaurin series? If we consider the Taylor series in a specific way, we get this kind of series. Are you familiar with this? Expansion of the Taylor series?
Ma'am, so here we are taking theta tends to 0, right?
Theta equal to 0, not tending towards 0. I'm considering theta to be equal to 0.
Ma'am, but if we take theta 0, then the whole expression will be 0.
If theta 0, then you are understanding?
Yes, ma'am.
Theta I am considering to be 0. This entire expression is based on, theta is equal to 0. So if theta is equal to 0, so I expect all of you are understanding this Maclaurin series, which is sine theta is equal to this. So now the expression, this last expression, phi to the power n plus 1 p, in the last remainder term, which represents the n plus 1th derivative evaluated at theta is equal to p, can only take the form of plus minus cos p or plus minus sin p, and as such can only take a value in the interval -1 to +1. Now, if this last value, this theta, phi to the power n plus 1 into p, this takes the value either cos p or plus minus cos p or plus minus sin p, then the interval within which it can move, that is plus minus 1. The value can be -1, the value can be +1, the value can be 0. So it will move in between the zone -1 to +1, regardless of how large the n is. So regarding the numerator, we are understanding it will move within the range -1 to +1, irrespective of the fact that how large the value of n is. On the other hand, n plus 1 factorial, which we have in the denominator, will grow rapidly as n tends to infinity. So in the remainder term, the numerator, this part, this part will lie in between -1 to +1. However, the denominator will grow rapidly as n tends to infinity because it is n plus 1 factorial. So it is moving towards infinity. In fact, much more rapidly than theta to the power n plus 1, because it is theta to the power n plus 1 as n is growing or n is moving towards infinity. In that case, this term also increasing a lot. However, the denominator will increase at a faster rate than this term theta to the power n plus 1. So I'm repeating once again. In the remainder term in this Maclaurin series, which is the expansion of the sine theta, what we are finding that as n tends to infinity, this phi to the power n plus 1 p, these will take any value between the range -1 to +1, or it will, better to say, it will take the values within the interval -1 to +1, regardless of the fact that how large the n is. On the other hand, theta to the power n plus 1 will grow as n tends to infinity, so that the denominator, which is n plus 1 factorial. Now, n plus 1 factorial will increase more rapidly compared to theta to the power n plus 1. Okay, so, if we combine everything together, in that case, we can say that this entire term will move towards 0 as n tends to infinity. This remainder term will move towards 0 as n tends to infinity. Okay, so this is taking, value within a small range. This is increasing at a faster rate compared to this. So this entire thing will move towards 0 as n tends to infinity. Hence, the remainder term will approach 0 as n tends to infinity. And we can therefore express Maclaurin series as an infinite series. Sine theta is equal to theta minus theta cube by 3 factorial plus theta to the power 5 by 5 factorial minus theta to the power 7 by 7 factorial, etc. So I hope somebody asked the question, how we got this thing. You are getting some idea at least from this expansion of the Maclaurin series. Okay, and for further analysis, you can check any trigonometry book. So whatever you did in the last semester, using that knowledge of Taylor series expansion, you can reach at Maclaurin series written in terms of sine theta, where theta value is equal to 0. We can expand the expression in this way, and we can finally write sine theta is equal to theta minus theta cube by 3 factorial, etc. Similarly, if we write psi of theta is equal to cos theta, then psi 0 is equal to cos 0 is equal to 1. Then we can take the successive derivatives in the similar fashion. Psi prime theta is equal to minus sine theta, second derivative minus cos theta, third derivative sine theta, fourth derivative cos theta, fifth derivative again minus sine theta, replacing theta by 0 and getting again the range within -1 to +1. On the basis of the derivatives, we can expand cos theta as follows. Okay, and following the same logic, this part will move within the limit -1 to +1. This will grow as n tends to infinity. This will again grow. However, the denominator will grow at a faster rate than numerator, which indicates this last value or the remainder term will move towards 0 as n tends to infinity. Hence, cos theta can be presented as 1 minus theta square by 2 factorial plus theta to the power 4 by 4 factorial, etc. So this is the note, on Taylor series expansion, or you can say Maclaurin series, which is giving you some idea how cos theta and sine theta can be presented in this format. Any question? No question. In the offline classes, generally it takes 2 days to understand this part. Students, start fighting regarding all these things. Why this? Why that? So I'm very happy that you are understanding everything. And no one has any question. Okay, so if you understand all these things, in that case, already we discussed the time path can be presented in this way, etc. This part is understandable, I hope. And next, the circular function part. Note 2. Okay. Regarding substitutability between theta and Vt. What I did here, I have replaced theta by Vt. Theta is an angle, and I am telling you theta is equivalent to Vt. Okay, where t is the time component and v is a parameter. Okay, so the question is how a trigonometric angle, cos theta, sin theta, can be presented as cos Vt, sin Vt, etc. Okay, that is, your question should be like this, whether really an angle can be replaced by some parameter multiplied with time, so it can be replaced by any number, any other number. It's not the angle, rather Vt is a factor multiplied with time. Okay, so here I wrote lating theta to Vt, just a minute. Lating theta is equal to Vt. I used this part, Lating theta is equal to Vt. We may write the things in this way. Now we can really consider theta equivalent to Vt, or angle can be presented in this way. That part I need to prove, or I need to give a note on this, that theta can be presented in this way. Yes, somebody had some question. Yes.
ম্যাম প্রশ্ন করা যাচ্ছে না, কারণ কি প্রশ্ন করে বুঝতে পারছি না, ওইটা একটু অসুবিধা হয়েছে। অয়েলেস ফর্মুলাটা একটু অসুবিধা হয়েছে সত্যি বলতে গেলে।
ম্যাম পুরো ক্লাসই পুরো লস্ট, মানে
Usually it takes 2 days to understand the matters, because people go back, see the things, and then come back, So that's why I am telling you, this is my experience, year after year. People go back and check, come back, they, tell me, okay, give us some time, and then we will see the matter, and then we will come back, because by this time we forgot all the first semester matter, trigonometry forgot, everything forgot, Therefore, I told you, I'm very happy that nobody is asking any question and everybody is understanding the matter.
ম্যাম আমাদেরও একই অবস্থা।
এটা কিন্তু খুব ডিফিকাল্ট কিছু না, একটু স্টেপ বাই স্টেপ আমাদের একটু বুঝতে হবে। ওকে, একটু বুঝতে হবে, আর কিছু জিনিস আমাদের একটু রিভাইজ করতে হবে। কিছু জিনিস রিভাইজ করতে হবে। আমি আরেকবার একটু পুরোটা রিপিট করে দিচ্ছি, তারপর আমি সার্কুলার ফাংশনে ঢুকবো। আচ্ছা, I think up to equation number 9 it was fine. Am I right or wrong?
Yes, ma'am.
Yes,
Equation number 9 is fine, তাই তো?
Yes, ma'am.
ঠিক আছে, বিকজ আমরা এটা দেখেছি অনেকবার যে এগুলো রিয়েল পার্ট অ্যান্ড ইমাজিনারি পার্টে ডিভাইড করা যায়, so that I can write the thing in this way. Okay. Next, the thing I discussed, that is regarding the convergence part, I think that is also easier to understand. I am not considering the numerator as such, because in an expression, if the denominator moves towards infinity, this entire expression will move towards 0. So PT will move towards PE. So if H is negative, in that case, we will have damped oscillation. Otherwise, we will have either explosive oscillation or uniform oscillation. That also we are understanding. Am I right? Is there any question regarding the convergence?
Ma'am, what about the monotonic part later?
Monotonic part, who are you? Whose question was this? I just asking who asked the last question. Udita, did you ask the last question?
Yes.
Regarding the monotonic part, whose question was there? That I want to know. Udita, you wanted to know it?
Yes.
Monotonic time path is related to the real roots. So this part I completed yesterday. So if the roots are real repeated or roots are real distinct, in that case only we will have monotonic time paths. Okay, so monotonic time path is related to the issue of distinct or repeated real roots case. Today I am discussing about the complex conjugate roots. In case of complex conjugate roots, we have the oscillatory time path. So the question of having monotonic time path is not appearing here. Got it?
Yes, ma'am. Thank you.
So yesterday we completed the monotonic path. Today whatever I am discussing, that is based on oscillatory path. Actually, we want to understand why we will have oscillations when the roots are imaginary. Why we will have this kind of thing. In case of difference equation, it is a bit difficult to make the things understandable as we cannot use calculus there. Okay, actually the underlying concept is same. However, we will be not able to apply calculus there. So taking the derivative of sine theta, cos theta, these things will be not possible there. And, it becomes difficult to make the people understand why in context of imaginary roots, we will have the oscillation. Therefore, coming to the differential equation case, when we are talking about the imaginary root part, I am trying to explain why we will have oscillatory time path when the roots are imaginary in nature. That we are trying to understand today. So for that matter, first I am writing the time path, and while I am writing the time path, I am finding that in the roots, there is some real part and there is some imaginary part. So H plus minus VIT. So separating out the real part from the imaginary part. And expressing the time path as I have written in equation 9. E to the power HT, A1, sine theta, this equation 9. A1 e to the power VIT plus A2 e to the power minus VIT. So in this form, I am writing the thing and getting the equilibrium. Now tell me whether equation 9 is understandable. Or again, if you have any question. Because 9 is the starting point for today's class. So at least we need to understand equation number 9.
Ma'am, yes. Number 9.
So everybody, those who felt lost, are you understanding equation number 9?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay, now I am using several mathematical as well as trigonometric concepts. Simply, mathematical and trigonometric concepts. This is not related to economics, and therefore we are feeling, we are finding the things to be a bit difficult. We are not discuss these matters on the regular basis because this is not actually economics. These are mathematics. There are some expansion of several series, trigonometry, etc. So these are absolutely mathematical things. We are using several things to explain our time series. So I'm repeating, we transform the imaginary exponential expression. Imaginary exponential মানে e to the power vit and e to the power minus vit in the parenthesis into equivalent trigonometric expressions so that we may interpret the complementary function as a circular function. Okay, so I have some objective. I want to interpret the CF part, the complementary function part, as a circular function. This circular function in turn will generate a cyclical time path of price. So my purpose or objective is like this, and therefore we are going for using several mathematical tools in our analysis. In the first step, so actually here we are doing 3 steps. Okay. In the first step, we consider the exponential. This you know. No difficulty is here. You know, all of you know this thing. E to the power x is equal to this. Is there anyone who is not understanding this expression?
Understood, ma'am.
It's clear, ma'am.
Okay, it's clear.
Yes.
It's clear to some people. I think it's clear to everybody, isn't it?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay, you know this thing. E to the power x, you know. Simple thing. Next, what I am doing, I am bringing imaginary variable, imaginary term. I am making x to be imaginary. So instead of x, I am writing I theta. And I told you why I am writing theta, because I'll present it in terms of sine and cos theta. Therefore, I could bring e to the power iy, I could write iv, iu, anything I could write. I didn't write that. I am writing theta purposively because I'll talk about sine theta and cos theta. Okay, so I am putting the matter in that way. However, the main thing is I am making x to be imaginary. X টা real ছিল যখন e to the power x লিখেছিলাম. Now I am making x imaginary. Okay, so I am repeating this expression in terms of I theta. So I hope there is no question regarding this. Fully understandable?
Yes, ma'am.
Okay, so please
Yes,
open
ma'am.
the microphone and ensure that you are understanding each and everything. Okay.
Yes, ma'am.
So then I just mentioned, I am following the principle of imaginary values. All of you know these things, all these things you know. You know all these things. I square is equal to -1, I cube is equal to -I to the power 4 is equal to 1. So all of you know this thing, yes or no?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay, maybe you forgot the thing. Please check the thing once again, however you did this thing. So in place of I square, I am putting the relevant value. I cube, I am putting the relevant value. I to the power 4, relevant value. I to the power 5, relevant value, and so on. Then separating the real part from the imaginary part. When I am expanding the series, what I am finding that all the values are not imaginary. So real part I am keeping here, imaginary part I am keeping here. In the similar fashion, I can expand the series for e to the power -I theta. I can do the same job like this. So up to this, is it understandable now?
Yes, ma'am.
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am. So no,
Ma'am.
you have to do it, you have to check it once again. However, in terms of understandability, the things are acceptable. Am I right?
Yes, ma'am.
Yes, ma'am.
Okay.
Yes, ma'am.
And these things are coming. Euler's relation. Okay. So first step is done. In the first step, writing e to the power I theta minus I theta, done. Second step, bringing Euler's theorem. Actually, these two parts I will like to replace by sine theta and cos theta. And really there is this kind of relationship with respect to sine theta and cos theta. Now to understand this, there is note 1. For any sine function, there is no economics in it. There is no statistics in it. This is simply trigonometry. There is nothing, related to economics. So once again, let's look at this thing. For the sine function, write phi of theta is equal to sine theta. Okay, so we are telling you, please write sine theta is equal to phi of theta. Okay. So it's a, sine theta is a function. Okay, a specific form of the function phi of theta. So far we talked about the linear function. It can be quadratic function. It can be cubic function. Now, if I use trigonometry, this function can be the sine function. Okay? Like any other function. We are familiar, I can write f of theta anyway. Any function, f theta. Instead of f, we are using the notation phi of theta. Okay? This phi could be a linear function. In that case, you will write phi theta is equal to a plus b theta. It can be a quadratic function. In that case, you will write a plus b squared theta. It can be a cubic function. So it can go on like this. Parabolic function, circular function. Okay. So we can bring geometry in our analysis. I can define f as a circular function, a parabolic function, ellipse. So we can present f in that way. In this case, I am using trigonometry and my f is a sine function. Got it? Not f, here the phi or phi, whatever you call. Somebody call this phi. So, phi of theta is equal to sine theta. So I'm considering the function a sine function. So I'm writing phi theta is equal to sine theta. I told you if I consider a linear function, I'll write phi theta is equal to a plus b theta. I'm not considering a linear function. Rather, I'm considering a sine function. Therefore, I'm writing sine theta. Okay, so if I write phi theta is equal to sine theta, then I can go on taking derivative just like a linear function. You can consider a linear function, then you can take derivatives, You can take derivative phi prime theta, phi double prime theta, for this a plus b theta, you can go on like that. Okay, or a plus b squared theta, you can go on like that. Similarly, for the sine theta, you can go on like that. So you are taking first derivative, second derivative, third, fourth, okay? And following the rules of trigonometry, the first derivative of sine theta is cos theta, the second derivative of sine theta is minus sine theta, third derivative is minus cos theta, fourth derivative is plus sine theta. So that I marked. Tell me whether you are understanding up to this. Instead of considering the functional form we so far considered in our analysis, here I am considering a sine function. As I consider a sine function, I can write the derivatives in this way. Understanding the matter now?
Yes, ma'am.
Yes, ma'am.
Utri, Abhishekta,
Yes, ma'am. We got it.
Yes, ma'am.
Prithviraj, Raunak. So understanding the matter now?
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Very good. Then in place of theta, I am considering the value 0. Suppose theta is equal to 0. Now if theta is equal to 0, I should consider phi prime 0, phi double prime 0, phi triple prime 0 and so on. Now phi prime 0 is equal to cos theta, which is cos 0. Cos 0 is equal to 1, that also you know. Sine 0 is 0, that you know. So it is going on like this. 1, 0, minus 1, 0, 1. It is going on like this. So now you tell me whether you are understanding this part. If I put theta is equal to 0, the derivatives will take these values. So mechanically, at least you are understanding this matter?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. Very good. Then I am using the Taylor series expansion, So this you can do for any function. Here, I told you phi is my sine theta. So I am writing the expression for sine theta. So in the last semester, when you considered the Taylor series, what was your left-hand side?
Fx means
Any f?
yes,
F
ma'am.
The
theta?
function.
The function. Okay, my function here is a trigonometric function, sine theta. So what should I write in the left?
Sine theta.
Sine
Sine
theta.
theta.
Okay,
Fine.
because my function is sine theta here. I didn't consider any other function. And I defined the function. Generally, when we learn the things, mathematical tool in the first semester, you don't have any objective. So you write f or phi. Here I have an objective. And I mentioned my function is a sine function. So I'm writing sine theta. And, I'm writing the Maclaurin series. I'm writing any standard Maclaurin series. F of theta is equal to 0 plus theta plus 0 minus theta cube by, you made did in terms of x, f of x. Okay. However, the things are same, similar thing you got. And in the remainder term, you got the function to the power n plus 1, p, n plus 1 factorial, theta to the power n plus 1. So once again, please check the math which you did in your first semester course. So now the expression, this expression. Now I am talking about this expression. So can you remember this kind of expression where you lost, looking at the Taylor series, etc. However, this is the natural thing. When you said that you are understanding everything, I understood nobody actually got anything. Okay. So sometimes it is better if you don't understand the matter. That is quite natural. So if you
Ma'am, please
remember,
explain a Maclaurin.
can you remember the Taylor series?
Yes, ma'am.
So for that matter, please check your first semester course and then come back. Next, if you have any problem, then we will check what we can do for you. Okay. So the entire Taylor series expansion, Maclaurin series, all these things you did in your just covered first semester course, mathematical economics course. Okay. So please check everything. Instead of sine theta, you got the general functional form. Instead of theta, maybe the variable was x, and instead of phi, the functional form was f. Rest of the things were identical. So now the expression, then I told you something about the remainder term, remainder term. So what is the basic nature of the series? That we can't understand properly if we don't understand what will be my remainder term. What will be my remainder term? Because if I can remove the remainder term, in that case, it will be an infinite series. Are you getting my point? If the remainder term is 0, in that case, this series can be presented as an infinite series. Are you understanding this matter? মানে একটা সিরিজ আছে, লাস্টে একটা accumulation আছে. So if that accumulation part vanishes, in that case the series will be an infinite series. Here there are dots, and at the end there is a heap. If you can remove that heap, it will be an infinite series. Clear cut dots will be here. So if the remainder term moves towards 0, the sine series will be an infinite series.
Yes, ma'am.
Okay. So we are looking at the remainder term here. Looking at the remainder term here. So whether we can make it 0 as n tends to infinity or not. And as I explained, as n tends to infinity, this term will move within -1 to +1. So let's look at the sentence once again. This expression phi to the power n plus 1 into p in the last term, which represents the n plus 1th derivative evaluated at theta is equal to p, can only take the form of plus minus cos p or plus minus sin p. Whenever I am taking the derivatives, either I am getting cos or sin. So if I consider the last derivative evaluated at theta is equal to p. So it will be, plus minus cos p or plus minus sin p, because if I take the odd ordered derivatives, it will come in terms of cos. If we take even ordered derivatives, it will come in terms of sin. Now, when I am taking in terms of cos, it may be plus, it may be minus. When I am taking in terms of sin, it may be minus, it may be plus. So I am taking the last derivative. The derivative in the remainder term will take the form of either plus minus cos theta or cos p or plus minus sin p, and as such can only take the value in the interval -1 and 1. Now theta or p has been replaced by 0. So cos 0, when I am telling that it will be within the values plus minus cos theta or plus minus sin theta, that in turn is indicating the values will be plus minus 1 or 0. Okay. So this numerator will range within the interval -1 to +1, regardless of how large n is. So n may be very large, then also this value will be within the band -1 to +1. Okay?
Yes, ma'am.
So only one person understood, or rest of the class also understood the things?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay.
Yes, ma'am.
Then I am talking about the other two terms, theta to the power n plus 1 and n plus 1 factorial. I am telling that as n tends to infinity, n plus 1 factorial will grow very, very rapidly. It will move towards infinity very fast because it is factorial. Theta to the power n plus 1, that means something to the power infinity, that will also grow. However, I am mentioning that since the denominator comes in terms of factorial, the denominator will grow at a faster rate compared to theta to the power n plus 1. Now, in the numerator, that theta to the power n plus 1 is multiplied with some -1 or +1, etc. And denominator is moving towards infinity very fast. So if we combine all the things, that is phi to the power n plus 1 at p, theta to the power n plus 1 divided by n plus 1 factorial, all the matters together, we are finding that this entire term is moving towards 0 as n tends to infinity. So this remainder term will be not there at the end, closing the series. So it will be an open series.
Ma'am, is there any rule is that factorial grows faster than exponential, or is
Yeah, this
like
is mathematically will always happen. You consider any numerical value and try it, you will understand. Okay, take n is equal to 5, say. Okay, and then something to the power 6 you consider, and 6 factorial you consider. Check what happens, whether this 6 factorial is greater than this or not. Okay.
yes, ma'am.
So always put numerical values when you have doubts. Okay, so if it is an infinite series, then I am just simplifying this right hand side and writing sine theta is equal to theta minus theta cube by 3 factorial, theta 5 by 5 factorial, etc. এতটা অবধি যদি you can understand, then you will simply understand this pattern.
Yes, ma'am. Understood.
Okay, following the similar principle, we can consider any other function psi. Previously, I considered phi. Now I can consider psi of theta. Psi is not a linear function, quadratic function, circular function, cylindrical function, ellipse, nothing. Rather, it is a cos. It is a cos function. So, psi theta is equal to psi of theta is equal to cos theta in my analysis. Psi 0 will be cos 0 then, and cos 0 is equal to 1. So first I am taking the successive derivatives, psi prime, psi double prime, psi triple prime, and we are getting minus sine theta, minus cos theta, sine theta, cos theta, minus sine theta, etc. Then we are putting the value 0. So psi prime 0, psi double prime 0, psi triple prime 0. So all these things are happening. And again, we are getting the values 0, -1, 0, 1, 0. All these things. You know? So it is moving within the band -1 to +1 once again. So the things which I have written here will be applicable in this context too. Okay, so first this expression following the Maclaurin series, okay, and then following the same logic, I can present cos theta as 1 minus theta square by 2 factorial, theta to the power 4 by 4 factorial, minus theta to the power 6 by 6 factorial. Because the last term has moved towards 0. এরকম যাচ্ছে তো 1 plus 0 minus something plus 0 something plus infinity দিকে গেছিলাম, লাস্ট এটা 0 ছিল, 0টা উড়ে যাচ্ছে, so it becomes an infinite series like this. আচ্ছা বলো, এখন বুঝতে পারছো?
হ্যাঁ ম্যাম, বুঝতে পারছি, তবে এটা আরেকবার পড়তে হবে, তাহলে হয়তো আরো ডাউট বেরোবে।
একবার পড়ে হবে না?
Every infinite series, if there is no last term as such, or if we can prove the last term is equal to 0, then we can just say that since there is no last term, it is infinite. Like, is that how it goes?
Udita, what is your question?
Ma'am, for infinity, if there is a last term, prove that it is infinite.
Not there. Is there any bound? If there is no remainder term, will there be any bound in the series, upper bound in the series?
No, ma'am.
So in that case, the series will be an infinite series or not?
Yes, ma'am.
So you know the answer to your question, okay? So if there is no upper bound to the series will be infinite series. Okay, so using these notions, of sin theta and cos theta, then we tried to present our time path. However, there we did something. We made an equivalence between theta and Vt. And if you do this part, I think everybody understood. The time path can be written in this format. I think this equation is understandable to everyone. Simply, if I consider theta is equal to Vt, the initial expression, in the initial expression, e to the power Vit can be presented by cos Vt plus I sin Vt, and e to the power minus Vit can be presented as cos Vt minus I sin Vt, and then we can write these steps. So please check if you are understanding this thing. Still, I need to clarify this part, this yellow part. However, simply if I tell, theta is equal to Vt, can we write this thing in this way? Yes or no? Now again lost? Or what do you think?
Understood.
Understood? This is equation number 9. So, if this is equation number 9, in this equation, in place of e to the power Vit, I am putting this, e to the power minus Vit, I am putting this, making some adjustment and getting this time path. Okay, so this is another presentation of equation number 9 in terms of sine and cos functions. Okay, so the next part, since you have another class today, that I'll do in the next class. So if you understand up to this, I'll start from this part in the next class. How theta can be presented in terms of Vt, or will there be any harm if we present theta in terms of Vt? আচ্ছা এখন বলো একটু বুঝতে পারছো?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay, so this part I
Yes,
still,
ma'am.
because next day I have to start from this part, substitutability between theta and Vt using the circular function, etc. Okay, so that is quite a thing that we will do in the next class.
Ma'am, can you please give my attendance?
Okay, I'm checking. Who are you?
Ma'am, number 78, Udita.
Ma'am, mine as well, 66. Oh,
66.
Yes, ma'am.
Yes.
Ma'am, Prithviraj is present.
Okay.
Ma'am, 85.
Orpor is absent or present? Okay. Roll number 62. Shomosri. Absent. Then Komal.
Ma'am, she's
Present, ma'am.
present.
Anyone else?
Ma'am, Prithviraj said to mark him present.
Huh? Also?
Prithviraj.
Yes.